5 expertos explican cómo los equipos de desarrollo de software se ajustan al cloud computing. Todo un reto continuo. Mientras que el software continúa devorando al mundo, las filosofías y tácticas utilizadas para construir ese software cambian constantemente. Pasar de la idea al software en funcionamiento nunca ha sido fácil, y las empresas que nunca necesitaron experiencia de vanguardia en desarrollo de software se están viendo expuestas a competidores más pequeños y ágiles. La solución a esto se ha denominado DevOps, una mentalidad en la que los roles de los desarrolladores de software y los operadores de sistemas ya no son tan separados como lo fueron antes. Esto ha cambiado la forma en que las empresas piensan en construir, probar y desplegar su software, permitiéndoles enviar actualizaciones con mayor frecuencia y ayudando a garantizar la confiabilidad. Tecnologías como contenedores y microservicios también están emergiendo para apoyar esta forma de pensar. Los contenedores permiten a los desarrolladores empaquetar sus aplicaciones con todas las dependencias externas con las que cuentan para hacer que la aplicación se implemente en varios servidores, ya sea en el hogar o en la nube. Del mismo modo, los microservicios les permiten a los desarrolladores dividir sus aplicaciones en muchas piezas más pequeñas que pueden modificarse o actualizarse sin tener que recurrir a todo el código base. 5 expertos debaten sobre cómo evoluciona este mundo, cómo estos mundos están cambiando y cómo pueden implementar algunas de estas ideas en sus propias organizaciones. Hay muchas opciones para construir software moderno nativo de la nube en este momento, y eso es tanto una bendición como una maldición, mientras que algunas de estas nuevas capacidades pueden desbloquear oportunidades de cambio de negocio, puede ser muy difícil entender qué herramienta es mejor para tu equipo. Esto es lo que tenían que decir. Vasant Ambara, cofundador y CEO, Openinnova. Una tendencia que todo el mundo está mirando muy de cerca es Kubernetes, el proyecto de orquestación de contenedores desarrollado originalmente en Google que, con mucho trabajo, allana el camino para que las empresas ejecuten sus aplicaciones a través de múltiples nubes públicas y centros de datos locales. La startup de Ambara en Seattle está trabajando en maneras de llevar los servicios de almacenamiento a Kubernetes, y discutió cómo el progreso en esta área podría dar como resultado que las personas que buscan a Kubernetes sean la capa de implementación para sus aplicaciones.
I think I'll try this one first. So hi, I'm Bassam. I'm the CEO and founder of a company called Upbound. A new startup in Seattle in this space, in the infrastructure space. And we are the sponsors of a CNCF project called Rook, which is really about dealing with stateful workloads on Kubernetes. So what I hope to do today is to kind of walk through some of the choices you have when you're running stateful workloads or interacting with stateful workloads on Kubernetes. Some of these are not so obvious when people think about running stateful in Kubernetes. So I hope to kind of walk through some choices and talk through some of the trade-offs, but feel free to ask questions, and happy to have this a little bit of a live discussion. So look, show of hands, how many of you guys have, well, let's start with the easy one, heard of Kubernetes? Okay, great. You're in the right room. How many are deploying Kubernetes today in production? Okay, so about 10-ish people. How many of you are running stateful workloads in Kubernetes? So, 1. Great. Okay. So the question was, is it running the stateful services themselves on Kubernetes or accessing stateful services through Kubernetes? And I meant the former. So I think there was 1 person. So just to level set, I think people describe Kubernetes in a lot of different ways. I'd like to think of it as the cluster operating system, just like Linux is an operating system for a single machine or a node. I think of Kubernetes as the operating system for the cluster. And as an operating system, it does a number of things. Most people kind of refer to Kubernetes as the container orchestration, which it does. but it does a bunch of other stuff that people don't talk about or don't highlight as much as container orchestration. So it's lifecycle management, scaling, all these automated features for rollout and rollback, service discovery. It's got its own views on networking. It starts to look more like an operating system for the cluster than it does just, say, a scheduler or orchestrator. The thing that I think gets probably the least amount of attention when people talk about Kubernetes is the fact that it actually exposes a portable cloud API. And that is an important strategic piece because it is, trying to deliver on the promise of writing once and running everywhere. And if you were to put your stuff in containers and run it in Kubernetes, for the most part, that's true. Kubernetes today is supported in all the different public clouds, including Amazon now, and by most platform vendors, including Docker and Mesosphere, and everybody's got some kind of Kubernetes implementation or a managed Kubernetes service. So if you were to put your code in containers and you don't really need anything outside of the Kubernetes space, the write once, run everywhere is actually fairly true. And we're seeing a lot more companies converging on Kubernetes and talking about how that's become a productivity enhancement, or how they've changed their entire operation to be Kubernetes based and how they've seen productivity wins as a result of doing that. The story falls short when it comes to storage. And so let me first level set on how we think about storage. So to me, storage is really anything that can survive the compute lifecycle. So in a dynamic environment like containers come and go all the time. Any kind of state that needs to survive beyond the lifecycle of a container, a pod, or a function is probably in the definition of storage. And so you'll hear different terms of this. You'll hear stateful, stateless. None of them are perfect. Persistent storage, you'll hear durable, long-lived. Those are all examples of how people describe what we're talking about here. And then there are different forms of storage. And so the most obvious ones that people think of when you think of storage is blocks and files. So these are volumes, things that you mount into your containers, but there are lots of different kinds. So it's objects, records, key value stores, queues. All these things are also stateful or persistent types of storage that need to exist beyond the compute lifecycle. So let's bring the two together. If we think about Kubernetes as being this platform abstraction and cluster operating system, and if we think about storage as being an important piece of every application and every service, how do they come together? And I keep hitting the mic. So, Kubernetes defines an abstraction, a portable abstraction for one form of storage, volumes. So that's block storage and file storage. So if you were to use the volume abstraction in the form of, say on the left here, persistent volume claim, it's an API that Kubernetes exposes, which is a request by essentially to provision a volume, and then it describes the properties of this volume. So if you wanted the size or the speed or any kind of annotations, you could describe that on the volume itself. And then on the right here, we have a pod that's using this volume. And if you're using this abstraction, you're actually able to run your service and consume volumes, block or file, anywhere that Kubernetes runs. For the most part, it still fits the write once, run everywhere mantra. And unfortunately, this is the only abstraction that Kubernetes has related to stateful workloads. It stops here with volumes. almost everything else that's exposed, like how to run and scale services, are all mostly on the computation or on the networking side, not on the storage and stateful side. And so if you're using Kubernetes, putting your stuff in containers, even using the volume abstraction, you're able to run your containers and you're able to interact with storage services that, for the most part, live outside of your Kubernetes cluster. So on the right here, whether it's public cloud managed services, things like EBS or Google Persistent Disk, or provide volumes to Kubernetes, or if it's on-premise and you're using things like Gluster or Ceph or any of the storage systems that are available, you're essentially able to write your application, and it consumes these volumes that are exposed by services that are outside of the Kubernetes cluster. And so what I want to do now is I want to introduce the Rook project and kind of walk you through some more options that are available to you when you're thinking about running state and interacting with stateful workloads on Kubernetes. So Rook is a cloud-native storage orchestrator. Think of it as an extension to Kubernetes that adds, one, more abstractions beyond volumes, and two, the ability to run stateful storage services inside the Kubernetes cluster. So those are the two things that Rook provides. It's open source, it's Apache 2.0 license, and it's hosted by the Cloud Native Compute Foundation. So it's a project for everyone. My company, Upbound, is a sponsor of the project, and that's why we like to kind of walk around and talk about it. So let me walk you through what that means. So what Rook does is it helps storage systems, things like Ceph, CockroachDB, Minio, Nexenta, and there's a bunch more coming, essentially run like a service on top of a Kubernetes cluster. So, and it does that by automating all of things that people usually do by scripts or others into logic that helps these services run within the cluster. And it then extends Kubernetes to be able to essentially provide these abstractions that run on these services. And we'll walk through this. So for example, with something like Rook, you now, if you wanted to, if that makes sense for your deployment, can run storage systems as if they were managed services inside your Kubernetes cluster. So think a typical deployment, say a bare metal deployment, if you're doing bare metal, or you're running outside of a cloud environment where you don't have these hosted managed services, and you still want to run a database, or you still want some block storage, Rook makes it easy to run that on the same cluster as your Kubernetes cluster. So and it uses Kubernetes itself to help manage these services and scale them and manage and do essentially what most services would do, what the cloud vendor would do outside of this environment. Another option is to say, well, great, if I wanted to do that, well, if I wanted to, I can have my compute cluster be separate from my storage cluster. So you're able to, say, run your compute on one side of the house and still use Kubernetes to manage your stateful storage services on the other side and scale them independently. So that's another option that's available to you if you were to use something like this. So to give you an example of what Rook does, say you wanted to run let's take an example where you're on a bare metal cluster, you have your own deployment, and you wanted the equivalent of, say, EBS or an S3 service that you wanted to run in your environment. With Rook, you can basically define a cluster using Kubernetes, configuration manifests. You could define the size of the cluster. You can define which devices you wanted to use, and then post that to Kubernetes, and then Rook would light up all the pieces required: the storage nodes, the mon, build quorums, deploy and run storage nodes to expose your own EBS or your own S3 service within your Kubernetes cluster. So that's a pattern. In this model, you are now running your storage services inside your Kubernetes cluster. And Rook does this by essentially following the operator pattern. How many here have heard of the Kubernetes operators? Great. And so essentially, it's continuously reconciling desired state, which is what you want to happen, with actual state, which is what's actually happening in the cluster. So if you were to, what's cool about this is if a new storage node shows up and it matches the desired state, then you'll see it deploy, become a new storage node, and become affiliated with the storage cluster itself. Or if something fails, then it's remedied and the system heals automatically as things come and go. And just like, say, Kubernetes does this with replica sets or with pods and deployments and others, a similar kind of thing is happening with stateful services in this case. So the other thing I talked about is that, and this is a relatively new thing that we're getting into, is the ability to provide new kinds of portable storage abstractions. So we talked about how volumes exist in Kubernetes. Within the Rook project, we are actually adding buckets and databases as a new abstraction in Kubernetes, and enabling many stateful services that sit behind them to essentially, extend the reach of the write once, run everywhere to things like databases and buckets. So you'll see us, I'll talk about how you can get involved, but definitely if this is interesting to you, you should definitely get involved in this project. So as an example, here's a persistent bucket claim, which is a new API that enables you to provision and manage and use buckets within your pods and your deployments without really knowing who the provider of the object storage is. Just as with volumes, Kubernetes gives you that promise today. And then similarly, if you wanted a MySQL database or a Postgres database, then you should be able to do the same thing. You should be able to say, I'd like a MySQL database as part of my deployment, and that you can write your app and use whichever favorite MySQL connector you need within your app. But the provider of the MySQL service could be RDS in one cluster, and it could be MySQL running in Kubernetes in another, right? That level of abstraction needs to exist, and that level of separation of concerns needs to exist for us to get to the point of write once, run everywhere, portable across clouds, portability across hybrid deployments. And that's why we're extending Kubernetes to do more and more of that as around stateful and stateful workloads. And so if you had that, you'd be able to say, now you have a choice. You could say, I can run my pods. They use a MySQL, a Postgres, or a bucket and a volumes, and they're now stateful apps, very stateful, use different kinds of storage. And the choice could be whether the provider of the storage could be a public cloud managed service, if that's where you deployed, or it could be in cluster, or it could be in a separate cluster. At some point, the author of the app shouldn't know or care. The cluster admin should set up the cluster with where they want the storage provider they should set up the storage provider when they're setting up the cluster. Make sense? Is this right? That's all I had. So please check it out. Again, it's a CNCF project. It's open. It's a pretty healthy community around this project. Here's a bunch of information for how to get involved. We're actively looking for contributors or people that want to help the project grow. It project has good governance and it's in good shape. So definitely help us here. If you're also interested in Upbound, come talk to me or Steve here, who's also from Upbound. And if this looks interesting, there's lots of opportunities at continuing to do similar stuff in here in Seattle. So thank you.
Thank you, Bassam.
Happy to take questions.
Do we have any questions from the room? Yes, up the
Bob.
back.
Hey, can you the last bit there using
Yeah. Sure. So the question is, how does the work to add abstractions like MySQL database or Bucket relate to efforts like the Open Service Broker and others?
Well, just to be clear, like Bucket, the database.
Definitely.
So this question, I want MySQL running on my cluster. One is running, so it has to extract.
Right.
That's the
That is. Yes. So there's a project called Open Service Broker, which I think its stated goal is to help broker access to managed services that are running in public cloud environments or other environments. And the abstractions provided by the Open Service Broker are essentially how to provision a binding to a service and an instance of a service that is running. And so that model works if everything looks like a service endpoint and a binding to it. That model is definitely fine. In fact, you can argue Rook should use that when it's talking to things like RDS or others, right? What we're attempting to do is with the Rook, we're actually trying to provide high-level abstractions like a Bucket, which could have commonality across the different providers of it. And then attempting to do a separation of concern where, just like volumes, there is a concept of a bucket and a claim, and that is vendor neutral and and also implementation independent, right? Both of those goals are not stated goals of Open Service Broker. And so I think that's where the design diverges. But we are, this is all in the open community. We'd love to figure out how we're actually talking to folks at the Open Service Broker team and trying to figure out how do these things, come together. But the end goal is, I think, is the same. We'd like to get the goal of write once, run everywhere to actually address the majority of what people run in terms of apps and services, and not just the compute and the networking piece. That's our goal here too. Question? So that's the question is, do you think that the Bucket implementation and the object store that's providing it could provide the same SLA as, say, a managed service provider would? I think that varies. A lot of it is a function of who's running the object store and what they're doing to run the object store. In some cases, some customers don't have a choice. For certain workloads, they need to have, say, on-premise and others, and that's what's available to them, and they work with a vendor, right, to do that. I think what we're seeing is essentially there's a fair amount of automation that has been built to run things like object stores reliably. A lot of that automation today is in public cloud vendors, and they obviously give you an SLA and they carry pagers and they do the whole thing. So one of the things to think about is if the automation increases to the point where, through things like operators and others, it becomes, say, it gets you 80% of the way, would it be efficient for an enterprise to run with the 20%, just handle the 20%? And I think the folks that are running any kind of stateful storage services in-house are doing that today. Is it the same SLA? Well, it's hard to say because there's no SLA contract between them and themselves, or at least, but that's it. I guess the thing that's more interesting to us is that the choice should be available, as opposed to it's one or the other, right? And certainly the choice, if you change your mind about where you want to run, you shouldn't have to go rewrite your applications when you do that.
I have a question. Oh, you go first.
Yeah. How does data persistence and data recovery in this?
So the question is, how does data persistence and recovery work in this tool? A lot of that is a function of the actual storage provider itself. So if you're looking at something like Ceph or Minio or CockroachDB or others that run on something like this, they all have provisions for recovering data and resilience around failures and dealing with failure cases. So what this provides is the ability to kind of marry that with Kubernetes, so that if a node fails in Kubernetes, that the storage provider can actually trigger its resilience facilities or healing facilities, or if things grow and scale, that as you add nodes, that the cluster itself grows and becomes stronger and faster. But each of the storage systems have very different ways of dealing with that. Ceph does it one way, Cockroach does it a different way. Some use erasure coding, some use redundancy replicas, and it varies by storage system. Rook is an orchestrator that sits on top of those. It's not actually the one that's doing the recovery and resilience. You had a question, Nathan?
That's actually what my question was. Thank you.
Okay, great. Awesome.
Anything for... No.
Thank you, guys.
Thank you.
Of course.
Edith Arbau, cofundadora y CEO, Launch Darkly. Antes de que la nube y la informática móvil lo cambiaran todo, el proceso de desarrollo de software se basaba tanto en objetivos de marketing como en cualquier otra cosa, pero esos días ya no existen. Las grandes compañías como Google y Facebook le han demostrado al mundo que usted puede construir un mejor software a un ritmo más acelerado mediante pequeñas mejoras continuas a su código, y Arbau esbozó para la multitud como los beneficios y los escollos ocasionales que han llegado junto con esta nueva realidad.
Yeah, thank you. I actually do have slides. This isn't just an excuse like the projector ate my homework. So I'm going to follow along with my slides while they try to... Do you think you can get it sorted out? I'll just put in my... yeah. All right, so I have a huge advantage because I can see my slides, and hopefully soon you can see them too. So I'm Edith Arbau. I'm co-founder and CEO of Launch Darkly. We are based down in Oakland, California. So I came up for this conference, which was great because prior to this, I was a product person at Concur, which some of you might know is it's about 4 blocks from here. But I actually started off as an engineer. So I started off as an engineer doing big software releases at Epicentric and Vignette. The way releases were built back then was pretty archaic when we look back at it. So back then, if you did a release, you would do a year release, you would hope somebody would install it, and you get feedback about a year later that whatever you wanted to build was not what people actually wanted. What happened since the 90s is the acceleration of business and people started doing faster and faster releases. I think Salesforce was the first person who really said, okay, let's do quarterly releases. And now when I tell people that we used to have a party when we had a release, people are like, wait, what? You know, a good software org is releasing multiple times a day. There are a lot of reasons why DevOps happened. I'm assuming that you're all in the DevOps track because you're in some way interested in DevOps. This will be really exciting if this works. So DevOps happened because just basically people needed to get stuff to the market a lot faster. There's a lot of issues with marketing if you only release once a year. Whatever you think you're going to build, it's usually too late to the market. Product people had a lot of issues with these year releases where you think you're going to get it right, you put out a feature that you like, and then it doesn't actually meet the market needs at all. The other issue with the long-lived releases, and I saw this really firsthand when I was an engineer, was that long-lived branches were really painful. How many people have had a branch that's lasted more than 6 months? How much fun was that when you had to merge it back in? Yeah. So long-lived release branches are really, 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 really painful. Something that's really dear to my heart is the other issue that I saw with these long-lived releases was that you would do all these testing before it got out to the field. You would have a tested platform matrix, you would try to get a lot of user feedback, and then once you got it out to the field, whatever you had tested was instantly obsolete. We saw this over and over at TripIt. We were a mobile app. We would try to test it in our labs, and then all of a sudden it would be out in the field with somebody on a version of Android running through an airport with a really low signal and a low battery, and just the functionality that we thought worked very, very well when you're sitting in front of your Wi-Fi with a strong connection suddenly failed. So the other reason for these shorter and shorter releases is so that you can get more efficiency and quickly recover from bugs. Ops usually almost always gets the shortest end of the stick. So when I was a younger engineer, we called the worst releases ones that didn't break but that destroyed data. So this was like a Sev 0 because when you started using one of our releases, it went in and deleted all your data, which might sound minor, except for we were selling to big newspapers. So when you started using this certain release, it went in and started deleting all their archives, which is literally their bread and butter. This was a really, really, really bad release. And what happened was, I was a young engineer right then, so I was the one that was kind of cowering in the corner. Our engineering director turned to our ops director and started screaming at him that it was taking so long to get a new release out. And I thought the engineering director was, to be honest, being kind of a bully and a jerk. He'd shipped this bad release, and he was trying to push the blame to the ops people. In hindsight, yes, our dev director was kind of a bully and a jerk, but he was right. If it takes 2 days to turn around a release and get it out to the field, and you have a critical error, that's just way too long. The other thing I learned from this, and you've probably seen it all in your own life, is when you're stressed out, when you have a bad release out in the field, that's when you usually make the worst mistakes. It's just a physical reaction that when you're under stress, I'll say I'm a little stressed right now because I don't have my slides, but your mind starts to churn and you say, fix it, fix it, fix it now. And that is literally when we have made the worst mistakes in engineering. So this release I was talking about where we had this critical error that was deleting people's data, we hurriedly did a fix pack A, and then B, C, and went all the way up to J. Like within about a day and a half before we had some level of stability, because it was just basically like this rampage of fix, 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 fix. And when you're in that hurried fix stage, you're actually breaking a lot of other stuff. So from all of this stuff, a best practice arose, and my company, LaunchDarkly, did not invent it. People like Netflix and Etsy have had this secret weapon, which they call feature flagging. So how many people already are familiar with feature flagging or use it? Great, about half. So I'll give an overview about what feature flagging is. So feature flagging is this idea that you can basically wrap features and then release them and then selectively turn them on. The old way of releasing code used to be that whatever you shipped was just on for everybody. A feature flag gives you this really nice ability that you could basically dark launch it, i.e. launch with it off, and then turn it on for whoever you want. This gives a ton of flexibility. A really good way that we've seen people use this is that you can ship something and then maybe turn it on for a beta user or a friendly customer. The really nice thing about this is that if you haven't quite nailed it, you just turn it off. And you can iterate very quickly instead of this, everybody gets it at that if it's broken, it's very bad. You could just say, okay, let's do these progressive delivery and start rolling out to different people. This has a ton of benefits for different people within the org. So I'm kind of going to walk through who benefits from this. The biggest benefit first is for developers. If you can release separate from a deployment, what you first allow yourself to do is get rid of really long-lived branches. The reason you have a long-lived branch is usually because you have some functionality that you don't think is ready for everybody and you're trying to protect it. The downside of this is that you have this branch that's deviating from your main and it's getting more and more and more fraught with peril, that the second you check in and it's going to break everything else. So if you can have these new features right in mainline but turned off for everybody, it actually gives you a ton of flexibility in making sure that everything is up to speed, that if you have a dependency that's changing, it's baked into your code. So the first thing feature flags really give you is they unlock the ability to do trunk-based development. The second real benefit for dev is this also then unlocks in that some of the biggest fights I saw within product and engineering were usually about when is something ready. Because ready is a really loose concept. You know, is it ready if I've tested it on every phone in the universe? Is it ready if it builds on my own machine? Is it ready? And then you get the fights you start to have that I've seen are QA gets very overprotective because they've gotten yelled at for bugs. And so stuff sits longer and longer and longer because to be ready is to be perfect. With feature flags, what you could do is you could start to decompose what does ready really mean. Is it ready if it's good enough for 2 users who've asked for it to look at it? So like something we did internally at my own company, Launch Darkly, was we were building SSO, and we had a couple customers who were really eager for it. And wow. But that's not my computer though. But there's progress, and the slides are great, and you'll see them soon. So feature flags are really, really, really powerful for developers to unleash themselves from this idea that everything has to be perfect the first time you release it. The second thing it really does then is for QA. Oh wow, this is really exciting. Woo. All right, I'm gonna go back 2 slides. No, I'm just gonna roll with this. All right, so feature flagging really gives everybody within an org a lot of flexibility in terms of who gets what when, and I'm going to walk through how it works within a dev cycle, which is where I was. Dev gets access to the features they need to build when they want to build. You don't have to wait for everything to be ready, particularly if you have dependencies on another team. You used to have to do these lockstep releases, where you would have to line up every feature and make sure that they work together and then do a big release. If you wrap stuff with feature flags, it gives you a lot of decoupling in terms of you can iterate one thing and make sure that it's working with another. In addition, if you're using a lot of microservices, it allows you to make sure that stuff is working between the different microservices at the same time. Tonight we test in production. The joke is that everybody tests in production. Sometimes you actually have a separate server that's not production. I wrote an article a couple years ago called Kill Your Staging Server, and the article was basically about my frustration around how many times I'd gotten everything just right on staging, and then the instant you ship it, it's different. Like your production server always is going to win. Like it's not like you can point to your customers and say, hey, but it worked in staging, just settle down. Production always has different data. Production always has a different load. Production always has use cases that you haven't thought of. With feature flags, what you could do is you could say, okay, I know that it's going to be different in production. Let me give myself this ability to ship something and then turn it off if it's not working well, or to turn it on for more people. We've seen this with our customers help them so much because they can shorten their cycles. In terms of if instead of spending 3 weeks chasing down something on staging, they can move stuff much more quickly to production. That allows them to get stuff to market a lot quicker. This isn't to say that with feature flags you should ship crappy software. I think that's why people sometimes get scared by the phrase tested production. This is just saying that, you know, if you're a good engineer, you realize that stuff is going to break in production. Why not give yourself an easy escape valve like a feature flag? Which leads me to the next one. Ops controls access to features. I told a story at the beginning of the talk about the ops person getting screamed at that they couldn't run a build quickly. Even if you have a really sophisticated build system, it usually takes about half an hour to push a new build. I've heard horror stories of people having like 4 hours to get a build together. That's an eternity if you have a thing broken out on the field. If you have a feature flag, what you could do is you could say, ops, it's 3 a.m., turn it off. Let's reconvene and do a stand-up Monday at 8 a.m. and figure out how we're going to fix it in a sane manner, instead of having to scramble with ops running a release that'll probably have a bug that you didn't think about because it's 3 a.m. The final thing that I'm going to talk about is that this also has a lot of really good benefits to not just the cycle of devs, ops, QA, but the bigger org. Product, as I said before, can push features out to who they want, when they want, independent of the engineering org. So for example, if there's a risky new feature, you could push it out just to your early adopters and get the reaction. Something we've seen is that the most expensive features are the features you've built that nobody wants. This has happened to me many times. Like, there's always these good assumptions of, oh, everybody wants this, you push it out, you ask your analyst for the stats, it's like, well, nobody even looked at that page. If you could figure out pretty quickly that your pet feature is actually not loved, you could kill it early, which is kind of a mercy of, you know, let's not waste any more time chasing this feature that actually isn't the right thing for us to be building. Marketing. Marketing launches without feature flags are really painful. You have this big 9 a.m. launch, East Coast time, which means 6 a.m. Seattle time, which means that people are up at 5:50 a.m., like all huddled around a box, like waiting for the moment to push play. With feature flags, what you could do is you could actually push everything live the day before, and then when it's time for the big launch, just turn it on, because you've separated out release and deployment. This alone saves a ton of heartache. It's really painful to be there at 5:50 a.m. and have the build not work. That's not the time you want to have figure that out. A really cool other use case is sales can control access to features. A case we saw a lot at Concur was that we would have a one-off feature that we built for one customer. We were selling to enterprise customers and they would demand this one thing. And though as engineers we hated this, sometimes there's enough money on the line that we started doing these one-off features. You don't want to have that deep in your code. That's when you start to run into trouble. So with feature flags, what you could do is you could say, hey, this feature is for Morgan Stanley, this feature is for Goldman Sachs, and then have sales control it. So the takeaway I hope you have is, one, feature flags are really powerful. They can save you a lot of heartache, and they have a lot of power not just within the development org, and which is where they originate, but also for the rest of the company. I have all the slides online, and they're beautiful. So if you wanted to see the first 10 of these, you could go and get them there. I left about 3 minutes for questions, and I thank you so much for being patient with the technical difficulties at the beginning. Unfortunately, you cannot feature flag life, but, but I'm happy to answer some questions now. Yeah, so the great question was, how do you achieve feature flags? And I apologize because I had some slides showing it. A feature flag is basically an if statement. So you have an if statement in your code of if this and then this. What you can then do is for different users, they get different paths of the code. When you get more sophisticated, so what you're basically doing is separating out, pushing the code from who can see it. And you could get really granular about personalization. For example, you could say, I want to block everybody from this IP from seeing a new feature because they're a competitor. You could say, I want to block anybody who has a GeekWire email address because they don't want to scoop our code. You could say, I want to enable people from this country because they're getting early access. This is something that something near and dear to my heart is Pokemon Go does this a lot. Like they'll block people who aren't a certain level from seeing some features just because the load on their system must be immense. You know, they have millions of people worldwide using their game. But happy to answer in more detail. Other questions? How do you turn on feature flags in a controlled way?
Yeah.
Yeah, the question is, well, how do you use this? So LaunchDarkly is a platform for controlling feature flags. You do not need to use us to use feature flags. We think we help. I've seen customers do a lot of different strategies. If it's something where they're concerned about load, they'll start at 2%, 5%, 10%. One of the cleverest customers I saw actually would get up to about 50%, and then at noon they would go back down to 0. And I asked why they were doing that, and they said, well, they wanted to go to lunch. And if something was going to break, they didn't want to have it happen over lunch. So they would get to 50% in the morning, and then in the afternoon they would ramp it up to 100. This is a really good strategy if you have something that, so Envision just talked about it in one of our case studies. They had a SQL query that was malformed that worked fine in the local box, and then when it went to production, just starting to bring down their sites, they just feature flagged it. Because it was feature flagged, they could just turn it back down to 0. It really depends on your specific scenario, but that's a usual good strategy. So the question is, how do you right-size feature flags? I think so. We've seen our customers do every different flavor. We've seen some customers who do it for every basically pull request. So they'll say every Jira ticket gets a feature flag associated with it. I've seen other customers just do it more at a migration level. Like if they're migrating from 2 systems, they use it as an overall switch. My answer is roughly to Nathan's question about culture. What works for your culture? You don't want to have excessive feature flags, but you don't want to have too many. I've heard from some of our customers that in a postmortem, they'll say, why didn't we feature flag that? And then they'll start doing it more and more and more and more because it's just an easy way to save hassle.
It's nothing like a good outage to help you measure right sizing.
Well, I am out of time. I'm sorry about the difficulties at the beginning. All my slides are online. Happy to answer any questions.
Thank you.
Pagmare Conetti, director senior de operaciones de productos, Marioneta. Antes de sumergirse en DevOps y el desarrollo de software ágil, debe asegurarse de que todos en su equipo comprendan cómo funcionan estos conceptos emergentes y cómo cambiarán sus roles. Este es un desafío de liderazgo, no un desafío tecnológico, y Conetti, quien lidera los equipos de desarrollo en Portland's Puppet, les dio a los asistentes algunos consejos sobre cómo tener estas conversaciones dentro de sus equipos lo más pronto posible.
Good morning. Morning. Gartner predicts that by 2020, 50% of the CIOs that don't transform their capabilities will be eliminated from their leadership positions. I can see many of the speakers over the course of the day this morning wanting to do shows of hands. This is really helpful because we're trying to learn our audience. So I would ask you all, any CIOs in this room? All right. How about IT managers? All right. How about software development managers or directors? Cool. Application developers? Operators? No operators. Okay. Okay, good. That's helpful. All of you are sort of caught in the vortex of this digital transformation and DevOps that we're calling. And to all of you, I posit that we have a few things in common. Your world is not green. Much of it is brown, maybe even some of it is scorched. You have one of everything, and the technology that you're learning about and hearing about and perhaps even trying doesn't really match with reality. Maybe you've had pockets of success in certain places, but it's hard to make it pervasive across the organization. The complication is that day-to-day integration between the old and the new is challenging, the seams. And you have competitive pressure on one hand, you've got compliance and regulation on the other. So balancing those different requirements can be difficult. And one of the things that we've struggled with a lot is measuring the ROI of your engineering investments. That can be hard as well. And finally, the implications of all of this to your job, to your organization, to your survival even, is that you've got to constantly be demonstrating productivity gains. Does this sound right? Yeah? Okay. And if you don't relate to any of this, let us say you're a cool cloud-native startup that was started in the last 3 years or so, and you don't really understand this messy handoff between dev and ops, then it's been nice knowing you. If you leave the room, I won't be upset. I mean, the whole focus of this talk is to be able to relate to that pain that we've all gone through over the last few decades, and to sort of see what the transitions will look like. Great. With that introduction, I'm off to the races. My thesis today is that container technology enables organizations to be more agile than is possible using traditional infrastructure. Let me say that one more time. Container technology enables an organization to be more agile than a traditional infrastructure-based technology. Now, what we'll do today is basically we will observe the technology aspects as well as the behavioral aspects of what it is like to use traditional technology, what happens or changes with the advent of containers and the container ecosystem, and what we can take away from that. Now, I am going to be using these terms a little interchangeably. I'm sort of making the leap from practicing DevOps to being agile to the business mission of delivering great customer value and also making money. So I'm sort of using them interchangeably, but I promise that I will make some connections as we go along. But before we get into the topic, I want to tell you a little bit about why me and what about me makes this so close to home. I have a pretty cool job at Puppet. It has a few facets, and the core objective of my team is to drive operational excellence in my organization. It has a few areas. One, growing healthy teams. From hiring diverse talent to making sure that the teams have the right composition across a geographically distributed workforce, to making sure they have the right playbooks and charters, and what they're doing in their team level connects back to the company mission. My team focuses on that. We're continually examining how we ship and deliver software. I've got some war wounds, perhaps many of you do, transitioning teams from Dev, Scrum, Fall, Ban to Agile. I'm also responsible for making sure that we are taking the rest of the company on the journey. It is not just enough if your teams are great at iterating on software. You've got to have collaboration as well as processes to go along and make sure that your marketing teams, your business system teams, your customer support teams are all able to actually deliver great products to market. So that's another part of the job. And then finally, I'm the chief of staff to the chief product officer. As a product company, it only makes sense that there's someone who's also trying to make sure that his ideas and initiatives are scaling across the organization. As to why, what in my career actually brings me along on this journey, I've spent over the last 20 years or so in enterprise and consumer software engineering across a variety of industries, tools, technology stacks, roles. One of the things that I'm really passionate about is the intersection between things. Of interest to me today is the intersection between software development and organizational behavior. So we'll do a lot of that interconnectivity as well. And as to why Puppet, in case you're not aware, Puppet has been around for about 10 years. It's a company that's large enough and has enough brownfield infrastructure and has a passion to try out its own software on its own infrastructure. And we are on this journey ourselves to move from that brownfield over to more containerized applications. And so I'm here to share my experiences with you. All right, so with that, what is DevOps? The gal who went before me talked about it a little bit, and I'm sure you've all already started on this journey. The State of DevOps Report 2017 basically calls out that DevOps is a loose collection of practices and cultural values that enable software teams across any type of organization, size, industry, to be able to get better software release cycles, better quality, better security, and fast feedback on their development. Now, while we're at it, I'll also go into what DevOps is not. It's not a complex outside-in framework. It is not a product. It is not something that's merely accomplished by reorging developers and operators into the same team. It is not a fad that has come and will pass. And it's not a destination, but it's a journey. And I'll make one plug today. I promise the only plug I'll make. The State of DevOps report, in case you haven't read it, is an excellent report that's been publishing for the last 6 years or so. The 2017 report has some gold nuggets in there. It talks about how automation and transformative leadership and lean product management can enable your organizations to get to better performance. So if you haven't read them, read them. And the 2018 report as well is actually, the survey is open currently and closes next week. So we would love to hear from you. In terms of why companies are moving on to DevOps, we've heard a lot about it. Even folks talked about it earlier today as well. I won't go into necessarily the business benefits for the business or the developer or the operator, other than to call out one thing on the slide, which is that the incentives for each of these constituents is different. So as leaders who are trying to drive this transformation in your companies, it is important for you to be able to actually address all of these incentives in parallel. Make sense? All right, let's transition then into being agile in a traditional infrastructure world. First of all, let me step back and define what traditional software delivery workflow looks like. Primarily, you have two different teams who are responsible for different portions of the stack. You've got an operations team that is responsible for the operating system. You've got a development team that is responsible for the application artifacts. The development team does its work, defines the features and capabilities, and it hands off those artifacts and the dependencies over to the operations team using some standard packaging constructs like RPMs. The operations team then deploys based on some blessed images that are following company policy, and adds on additional things like logging and monitoring, and pushes that image out into production. Developers work on more features, and they continue to make this transition happen and hand over those capabilities over. And the ops team will deploy those changes in addition to deploying changes like patches for like OS vulnerabilities and things like that. Now, what it means to be agile in this world, many companies, including yourselves, I'm sure, have started to deploy a few practices to help you to be more agile. One, the concept of using infrastructure as code. In other words, describing your infrastructure itself as code enables you to have speed and simplicity of deployments. Operators are able to do that. There's a dramatic reduction in risk and failures, right? And then you have consistency across a large fleet, so mistakes are fewer as well. And generally, there's lower cost to your organization because the operators can automate the mundane and start to focus on the high-value work. We've also seen customers and companies deploy the concept of canary deployments, what we used to call in software A/B testing. In hardware, basically trying to deploy to a small fleet of your infrastructure with a lower confidence point, and then being able to see how that goes. And then CI/CD for your infrastructure code itself. Continuous integration and continuous delivery for the code itself, again, gives operators more flexibility at lower risk. And it also gives a lot of operational control to your organization to manage change. Imagine doing a pull request review sitting in your pajamas at home as opposed to trying to do the same in a large change control board meeting, a fancy meeting, right? So to make all of this real, I will also share some of Puppet's experiences. Our flagship product used to ship every 3 months. We then found that our customers were not able to adopt every 3 months. They were adopting at a much slower pace. but that doesn't mean we have to ship every 6 months. With our own leadership support, this was only last year, believe it or not, we transitioned from shipping every 3 months with a pretty fat hardening period to shipping every sprint. It was hard, but it was achievable. And what that did was some really cool things, right? First of all, it gave us that fast feedback. We have a customer zero program, which is basically our SRE team using our software. We've got a professional services organization, which is also able to give us that feedback and tell us how we're doing. So that's awesome, right? What we also got through that, which I'm a huge fan of, is small batches of work. So when you're doing small batches of work, I mean, the gal before was talking about feature flags, your ability to push things out and get feedback and reduce the risk of the eventual deployment is just amazing. And by the way, in this process, we also started to burn down technical debt. Now, those parts were all good, but the parts that were really challenging for us were around behavior. How do we make commitments and keep commitments? Are we paying lip service to continuous improvement, or are we actually doing it? Those were some things that we found to be pretty challenging in the process of going through our own Agile transformation. And one of the biggest ones that we've learned and have actually made some decent progress around is, what is our shared understanding in the company around Agile? Mindset over practice over tooling. I can confidently say that that's something that we're starting to see across the entire organization. Now, traditional infrastructure, in spite of all of that learning that I just talked about, being agile and everything, is going to only get you so far. Why? Because at the end of the day, pace of iterations are still slow. The choice that leaders such as yourselves and I have are still kind of messy. On one hand, we still have this clunky handoff between developers and operators. We've also tried a different alternative, which is building teams where the development teams have a deep domain expertise in operations. That's also hard to do, right? There continues to be a proliferation of design choices, infrastructure choices. For example, regardless of how hard you try to bring all of your teams with like your Spotify guilds and things like that, we notice that there are silos. So what ends up happening is every team has a bespoke way of doing high availability, for example, or has a bespoke way of doing metrics and data collection or telemetry. So that consistency that you're going for is really hard to find at the end of the day. And infrastructure tends to be tightly coupled, which means that developers are scared of making changes. And that is the antithesis to being agile, right? And finally, the design decisions that engineering teams are making have a pretty big impact on operations teams, but the operations teams can do absolutely nothing about it other than to receive and wait and try to remediate. So now let's explore what the container ecosystem does to this entire landscape. First, what you see on the left-hand side, besides my poor drawing skills, is a traditional virtual machine-based application stack for deploying an application. What you see on the right-hand side is a portable and consistent environment for development, testing, and delivery of the same application. Container technology offers the ability to separate applications from infrastructure, just like VMs did the separation between OS and bare metal. And when we talk about containers, we're not just talking about that immutable artifact that you have put your application into. We're also talking about this thing called an entire ecosystem, right? You've got a scheduler. You can't have all these containers running around. You've got to have a system of actually pulling them all together. You've got container registry, and you've got a host of services and tools. All you got to do is look at the badges of all the folks who are walking around at this conference, right? Lots of different things that make up the container ecosystem. Now, how do containers overcome traditional software limitations? Let's look at this on both angles. First, let's look at it specifically from the context of containers themselves. As one of the other earlier speakers was mentioning, developers can package all of their dependencies into the container itself. Applications are isolated from one another. The runtime environment doesn't really vary across dev, staging, and prod because the same container is being promoted across those environments. Developers gain a new level of independence with respect to the underlying operating system. I remember the times when if I wanted to push a software upgrade, push software features, I would have to wait for the underlying OS upgrade. You no longer have to do that. We're also starting to see a similar deployment workflow across various teams that are operating on containers, even if they're on completely different languages or projects. What does that do? It gives us portability for developers inside the teams. Career development moves, going to work on new software, that type of stuff. As well as it gives operators flexibility to start writing some standard tools. Now on top of that, when you add the container scheduling capabilities, you end up with more standards. Just yesterday, I was listening to a podcast from Google about observability and how you can improve that in the container ecosystem. You have standards in metrics and data collection. You've got a standardized service restart capability. You've got, it's much easier for operators to take deviant hardware out of commission when they need to. Operators have portability across different hardware and different cloud providers. And if you're using a platform like Kubernetes for container orchestration, which gives you that stability across your development environment, then that gives you abstractions as well for various cloud providers. Now, for the record, I'm not saying you must use Kubernetes. If that's your choice, that's great. If you have a different choice, that's cool as well. So these are all some of the benefits that you get by moving to a containerized ecosystem on the technology front. Now let's look at the organizational implications. Developers are held more accountable. They are more accountable for their design choices, for their software engineering choices. And what does that do? That gives them an opportunity to get faster feedback from their counterparts as well. There is actually a greater separation of concerns between developers and operators. For example, Kubernetes provides an abstract representation of infrastructure to your software developers, and it provides a really great way to describe your application requirements to your operators. So these folks can actually literally start operating across an API boundary. Back in the day when we talked about DevOps, we used to say developers need to have empathy for operational operators and their pain. You don't even need that anymore, because you have this interface through which they can interact, and there's cooperation, rather than having to try to figure these things out in meetings. And finally, the third piece I would mention is that adding new capabilities to existing suite of portfolio of products has historically been very challenging in traditional infrastructure environments. What does that do? It makes developers have to have this tendency of shoving more and more services into one monolith, making the monolith even bigger, because they're worried about approval processes inside their organizations. With containers, you end up actually having an ease of provisioning smaller, more contained services, which means what? Your pace of innovation increases. So lots of different operational behavioral changes as well that we see inside the organization. All right, so let's take stock. We've talked about what it's like to develop software in traditional infrastructure and the organizational implications. We've talked about what it's like in the world of containers. Many organizations that are trying to adopt these practices and technologies, it's not FOMO, it's not the fear of missing out like my teenager would say. It is real business impact, right? They're doing this for the sake of actually being able to change something in their business, and that is absolutely, believe it or not, that is absolutely existential. Now, the very fact that you're here means that you're interested in being on that journey. And where you go, of course, is going to depend upon your unique organizational objectives, but I will leave you with a few takeaways. On the technology front, start small. Start with something that's not mission critical. We do have a customer who went straight and wanted to containerize their SAP applications, more power to them, but that's not what I would recommend. Start small. For example, at Puppet, we have this tool called Robbie, which you can log into to go see who are all the new employees who joined your organization. Go containerize that, right? Almost every company has one of those in-house applications. Start small so that you have a chance to learn from that experience. And I might be saying something controversial here, but make your developers learn how to use Kubernetes, but not how to set it up. There's a difference. So the point I'm trying to make is this. If you don't have to run your own hosted Kubernetes in your company, don't do it. It's a huge distraction. If you do in fact need to do it, and it's essential for your business practices, whatever they may be, compartmentalize them. Because what I'm trying to drive for is a separation between those who are going to focus on building software versus those who are going to focus on the tools. believe me, it's a huge distraction, and we have tried to figure out how and where our SRE organization is going to be involved versus where they're not. And if you can afford it and you can use it, then use GKE or a hosted solution like that so that you don't have to worry about that part at all, and you can focus on the actual deployment of applications on top of your Kubernetes environment. And this piece is still it's still emerging, but I would totally recommend that you start to look at opinionated CI/CD tooling for how to deploy into Kubernetes. There are some tools that are out there. The point of this is that back in the day when you were trying to employ CI/CD for your traditional infrastructure, things are still pretty bespoke. How they are in your organization is very different than how they are in mine. However, with the container ecosystem, a lot of standards and patterns are starting to emerge. So I would recommend starting to look at that so you don't have to do that on your own. On the organizational front, make sure that there's leadership alignment. Make sure that your leadership, your business, understand what it is you're trying to do with your transformation journey. Because believe me, I've been on both sides of that. And the difference between having leadership alignment and not having leadership alignment is the difference between action and malaise. This is critical. Make sure that you have that, and if you don't have it, go for the right sponsor and go and persist until you have it. Again, going back to that FOMO point, be realistic. Understand what your organization's capabilities are, what your organization's culture is and appetite is for change, and then set realistic goals. Absolutely, set aggressive goals, but make sure that they're realistic and achievable. Go back to Agile basics. What do I mean by that? Continuous delivery of value. Always be working on the most important thing. And be ruthless about eliminating waste. And this could be in the form of useless meetings. This could be in the form of deprecating old software, letting your customers know. But waste elimination is one thing that actually gets off the table pretty easily because people constantly go after the next shiny new thing. And then I'll add another piece, which has also come as a lesson learned the hard way. Don't underestimate team health. There's a great book called Drive by Daniel Pink, which talks about 3 things that developers need in order to be happy in their, not just developers, anybody in their workplace. Mastery, autonomy, purpose. Their ability to learn new things, their ability to be empowered and autonomized so that they can go and solve problems, and they're being able to be tied back to purpose as to what the larger purpose is. So no sacred cows. If you are constantly looking at how you can improve your team's environment to be able to be successful, then you're going to see great things happen. And finally, I'll leave you with a saying from William Edwards Deming: be learning all the time. According to, I don't know if you know this person, he was a great statistician, professor, quality guru back in the 80s. He was also awarded some great medals by President Reagan. Learning is not compulsory, but neither is survival. Thank you for your time. I will be around in the hallways as well. If you have questions, I'm happy to take them. Yeah, it was fun being here. Thank you for being here.
Tamar Elam, miembro de IBM, Nube de Próxima Generación y DevOps, IBM Research. Las empresas que descomponen sus aplicaciones en microservicios disfrutan de una serie de beneficios gracias a ese movimiento, pero rápidamente descubren que necesitan algo que los ayude a administrar todos esos microservicios. Mucha gente piensa que la respuesta es la malla del servicio, y Elam explicó cómo Istio, un interesante proyecto de malla abierta de servicio desarrollado en combinación por IBM, Google y Lyft, evolucionará en los próximos años.
Thank you, and I'm happy to be here today, this afternoon. So my name is Tamar Elam. I'm an IBM fellow, and I work in the Watson Research Center in New York. And I am going to talk with you about the journey that led to Istio. Now, before we even start, a little bit of a show of hands. So raise your hand if you know what is Istio. Okay, quite a few people. Raise your hand if you already had a chance to download Istio and play with it. Okay, cool. All right. So I've been working in this area longer than I care to admit. And
I'm lucky to be able to witness and also to contribute to the evolution of ideas in the space of cloud, DevOps, and microservices. So if you don't mind, I'll take you to a little bit of a short trip back in time. So who remembers 2004? Who is old enough to remember 2004? I know you are. So back in these days, software was developed in a quite different way. And we had developers and we had operators. And around 2004, people, including myself, started noticing the gap between developers and operators. And this gap was organizational, and this gap was also cultural. So operators were used to doing things quite differently, lots of manual processes. And this miscommunication between developers and operators led to a lot of inefficiencies and unpredictability and risk. So back in these days, I started working on technology that will alleviate this problem. And basically, I came up with this idea of a desired state-based management, where we had a language, and that language is something that both developers and operators define the desired state of the system. And then I worked on techniques to dynamically generate the automation to deploy an application based on that desired state model. And it was messy. It was very messy. And the reason why it was messy is because there are lots of interdependencies between different software components. And these interdependencies led to very fragile automation. The automation was fragile because we had lots of temporal dependencies between steps of the automation, and also because we needed to copy a lot of configuration data from one place to another, from one tool to another tool to different hosts and stuff like that. All right, so fast forward to 2009. 2009 is where the DevOps term was coined and the DevOps revolution started. And it was cultural because we brought together developers and operators to work together since the inception of the project. And it was also technological because it was about, rather than having manual processes, now automating everything, automating the configuration, automating the deployment of the application, and versioning control everything in a consistent, unified process, which is the continuous delivery process. So that was a big step forward. Nevertheless, and this, big step forward, repeatability, less fragile, less risk, reduced risk, so this was all good. Nevertheless, software was still very complicated. It was still a monolith, and these nasty interdependencies between software components still existed. And one life cycle to something which is that big, it's very hard to modify. And microservices. So around 2011, the conversation really expanded. So if we focused on deployment and configuration, now we start talking about development and management, and we start talking about how to develop your code in a way that it's going to be easier to manage in production as a continuously running service. What are the architectural patterns and what are the design patterns that are going to simplify the code so it's going to be easily managed? So the goal was agility, and the mean was loose coupling. And when I say loose coupling, I mean loose coupling which is obtained by using consistent, well-documented APIs. Loose coupling which is obtained by denormalizing the data. And loose coupling which is obtained by standardizing the way we're dealing with dynamic binding, the way we bind each other, the way with configuration. So in one word, loose coupling basically means that you have an entire team, a small team, that is taking a full responsibility for the microservice since the development to the time that it runs and managed in production. And that these separate teams, separate independent teams, can work on different microservices and they don't need to coordinate. That means that they can make much faster progress, much quicker progress on developing these microservices and running them. It's also about resiliency, and part of the cloud native principles is how you deal with resiliency through patterns such as circuit breakers and bulkhead patterns. So obviously, now that you know a little bit about my background, you know why I was really excited about microservices when they came out. So before I continue, I wanted to point out another thing. So if we talked about DevOps, we talked about microservices as the two pillars for agility. Containers is obviously the third pillar for agility. And that's because containers are portable. That means that development and production environments are similar. There are no differences. So they're development friendly, they're lightweight, and they're very suitable for cloud native. All right, so I was very excited about microservices, and I'm working in IBM research. So I took a team and we started thinking together about what can we do in order to help our customers simplify the way they develop microservices, they deploy them, and they run them. Now you may think, okay, why would we simplify microservices? Because microservices are already simple. That's the main premise for services, they're simple. And it's true. So basically what's going on now is the complexity is shifting. It's very easy to develop a single microservice, and a small team can contain the work, and they don't depend on anyone. But you're going to end up in a situation where you have an application that is running on the cloud and is consisting of multiple interconnected microservices. In fact, it's a very dynamic environment. The whole idea is to get to agility. So that means that you're contributing new code, new versions. And at any point in time, you're going to have multiple interconnected microservices. And for each microservice, you may have multiple different versions running side by side with traffic splitted across them. So in that environment, how do you gain insight? How do you understand what's going on? Who communicates with who? How do you ensure security? And how do you troubleshoot? So that's the questions that we're trying to answer in IBM research. And we took a step back and we thought about, okay, we need a microservice mesh. We need a platform that is going to enable our customers, the enterprise customers, to go and develop microservices. What are the properties of this microservice mesh? And this is what we defined. So we wanted it to be a polyglot. We didn't want to constrain ourselves to just Java. That was one property. Second, we didn't want to require any changes in code. So you already have your application. You don't want to rebuild it. You don't want to restructure it in order to include some libraries, right? You don't want to necessitate that. Okay? The third thing is we wanted to enable experimentations and insight. And that's really important because when we talk about agility, we don't just talk about the speed of delivering new code. It's not just about speed. It's really about insight. You gain insight, and the insight informs your next steps. Of course, we wanted to be resilient, and we wanted to be able to do resiliency testing. And we also wanted it to be simple. Okay, so this is our 5 goals. And based on these goals, we defined the following principles. Because we wanted it to be a polyglot, which means that you can run your microservices in any language, we externalized the logic of the routing, the load balancing, and the failure handling as a separate process, which is a router, which is running side by side with the application. So it's a separate process. In the container world, it's going to be a different container. In Kubernetes, it's going to run in the same pod. Okay, and by doing that, we also achieved the first of all, we achieved the property of polyglot because you don't have to rebuild your applications with libraries because the logic is externalized. So you have 2 different independent life cycles, and the sidecar is part of the platform, but the application is something that you control. We also achieved the second property because now we don't require any changes to the cloud. Okay? In order to enable experimentations, we thought we need smart routing. So smart routing based on the content of the request in layer 7 means that you can split the traffic based on all sorts of criteria. So it could be based on the percentage base, which is useful. It could be based on the content of the request, such as the geographic location or user identity. That allows you to do A/B testing, to run 2 different versions and do A/B testing. So we needed that to be configurable, which means that our sidecar must be configurable with these routing rules that will allow splitting the traffic. The other thing is we wanted resilience, right? So for resiliency, we wanted to be able clearly to program the sidecar with failure handling parameters, timeouts, and retries. But we wanted more than that. So remember, each individual team is working on an individual microservice and they don't coordinate, right? So every one of them comes with their own timeouts and retry parameters in that interconnected network. But we don't know what's going to be the interaction, the interplay between these parameters, because lots of very weird things can happen with this interaction. So what you really want to do is you want to test the resiliency of the entire service mesh. Okay? So how do you do that? So we came up with the idea of injecting delays and failures that are very localized with control in particular places in the network, so that you can simulate a failure and you can see the effect. You can see how the service mesh, how your application behaves as a whole. So that was something that we needed in that sidecar, the ability to do that. And last, we wanted to be easily used. So think about all of these sidecars controlling the traffic and a centralized control plane that allows us to define all of these rules and to push them into the sidecar from a centralized location. So these are our design goals, and we went and prototyped and implemented it, and that's what became the project Amalgamate, which we open sourced in May 2016. So as you can see, we have a control plane, and we have the sidecars, and we have multiple versions running side by side, and you can configure the routing rules between them, and you can inject failures. So 2016 was a very interesting year because based on Amalgamate, we started a conversation with Google. And I think it was very obvious that the concepts are valuable and that they go beyond the value that Kubernetes already provides. And we all love Kubernetes, but that went to the next layer. We also, another thing that happened is that the company Lyft open sourced Envoy around August 2016. And Envoy is, if you don't know, it's a C++ programmable router that is very highly performant and is battle tested in production. And it's programmable, so we really liked it. And we thought that's going to be a good implementation of our sidecar concept. So it was a very natural decision for IBM, Lyft, and Google to come together and to decide, hey, let's work together, let's take the Amalgamate concept, let's take Lyft, and let's work on something together that is going to be this and much more. So around August 2016, we started working together, and in around May or June 2017, we announced Istio. And during that period of time, we're busy creating Istio. So you see, this is the architecture of Istio, and you see the control plane, which includes Pilot. Pilot basically includes all of the concepts that we put in Amalgamate, so we just delivered the code as this Pilot component, which really configures the routing rules in all of the sidecars. We also worked with the Envoy community in order to put in Envoy the ability to inject delays and failures, because that was something that was missing and it was important to us. And we also worked with Google in order to expand the capabilities of Istio. So now we have two different new components. We have Mixer, and Mixer is a central point that you can collect telemetric data, but it's also a place where you can define policy that governs each one of the communication between the microservices through role-based access control. And we have a new component which is called Citadel, and it was previously known as Istio Auth, that is responsible for the authentication. So this is a really nice example of sort of the community coming together in order to solve an industry issue, and it's also a lot of fun to sort of work together. So in the time left, let me just go quickly through the capabilities of Istio. So as I mentioned, we have intelligent routing, and intelligent routing allows A/B testing and canary releases. This is two different patterns of intelligent routing that you see here. Traffic steering, which is basically, okay, I'm gradually moving the traffic to the new version, to service B prime, and that allows me to do some canary testing to see that everything is good. And then the second one is a little bit more complicated, where I'm looking at the content of the request. So I route all of the iPhone users to the service B, and to the service B prime, and all of the Android users to service B. And then you have here an example of a rule which is even more finer grained, and it basically defines that only user JSON can see version number 2. And that is obviously useful if you want only the testing team to see particular versions so that you can test it before you're making it public. Okay, so we have resiliency, and resiliency is achieved through timeout and retries parameters that are configured in all of the sidecars. So you can easily configure this, and the first example that you see we're basically putting a timeout of 10 seconds. And in the second example, we're also limiting the number of attempts to 3. So this can easily be done through these types of rules. More than that, we are able to inject delays and failures to test the resiliency. And here you see an example where we're introducing a fixed delay of 2 seconds in a particular place in the network. So this is a proof of concept that we worked in IBM Research in my team. And what it's doing is basically it's providing a simple dashboard that allows you to easily control these configuration parameters and inject delays wherever you want to inject them. Then you can visualize the effect in the network. So what you're seeing in that picture is every bar, every colorful bar is a microservice. Then the gray area is the communication between these microservices. And the pink area is the ratio of these requests that are coming back with error codes. When you look at this, when you inject a failure, if you have a problem, you're going to see the effect visually very, very clearly. And what you're going to see is the area that is pink starting to expand, and then it's starting to expand to other areas of your mesh. So obviously you don't have resiliency because you have the cascading failures. Okay? So we have the policy, and I mentioned this, so through Mixer you can now define role-based access control. There is a way to very flexibly define role and role binding, and Mixer is also extensible, so you can extend it and you can integrate it with your own favorite product, organizational product, to enforce whatever rules you have. We also have telemetry collection, and this is something that customers want to use first because it's easy, it's out of the box, and it gives you a lot of valuable data, just like out of the box. And so just by the fact that you're running all of the traffic through Envoy, and Envoy is a router at layer 7, that means you have a lot of available data. So that means you're getting the bandwidth, the latency, the protocols, the error, the return codes, all of that, the latency, yes, I did say latency, all of this, the logs, and all of this is available to you, okay? Now, we are also integrating with other open source projects in order to do the rich data collection. So we're using Prometheus for metric and Fluentd for logs, and Jaeger for tracing, and data visualization can be obtained through Grafana. And again, since Mixer is extensible, you can add your own favorite tool to process the data and to do the visualization of the data. So you're gaining insight. And this is the first thing that the people want to do. They want to gain insight. So this is just like showing you some of the visualizations that are obtained through different open source projects. Okay, let me talk a little bit about the status. So we just released 0.8, and there are lots of new capabilities. It was a major release leading to 1.0. And what we did is we revamped the traffic management model. So we reorganized the way rules are defined, and now it's more like host-centric. We also addressed the communication between Pilot and Envoy. So now it's streaming-based, which means that it's more performant and it's less error-prone. We changed the way we're dealing with gateways. And we also have a feature which is called Istio a la carta, which allows you to just deploy some portions of Istio. For example, you can only, because it's all loosely coupled, right? So you can only Pilot plus Envoy and gain this smart routing if that's what you're interested in, for example. This is not in the list, but we also started implementing something which we call Istio multi-cluster, which is obviously very valuable for in the hybrid cloud space. And we have a vibrant community, which is really nice to see that there are lots of startup companies that joined right from the beginning and are contributing. So it's really very nice to see all of the work that is going into this project. So I started my presentation talking about the past, and I want to finish by looking at the future. So Istio and beyond. I just like to mention 2 different experiments that we're doing in IBM research, which leverage the Istio capabilities, but is going much further with them. So one of them is something that we call Istio Analytics. And Istio Analytics, so as I said, we already have an integration with Open Tracing and with Jaeger to do to understand them, to trace requests through the chain of microservices. Here we're taking it a little bit a step further, and what you're seeing here is that we're doing some statistical analysis of the average and averaging, and we're able to break a request in order to understand what is the exact latency of the communication, the average latency of the communication, but also what is the compute time, which is the yellow bar there. This is the compute time. How long does it take to compute before it can go to the next microservice? Further, what you're seeing is some green needles over there. And these green needles is basically, we're comparing 2 different versions. So we're comparing these two versions, and if they're quite similar in the compute time or the latency, then you're going to get a green needle. But you have one case here, if you see here in the bottom, where you get a red needle. And red needle means that the new version is much slower than the old version, which may indicate that you have a defect, and you may want to take a look about what's going on there. So this is all going into A/B testing. And when we started this, we started A/B testing with a single microservice. So we looked at the single microservice and we compared it with the older version. But here we're looking at the entire network, because if you change one, there could be some effect on other places in the network. So that's what we're doing here. And then the last experiment that I want to mention is we're playing with AI techniques in order to automatically auto-tune the failure handling parameters. Because one thing that we heard from our customers is that they actually have no idea what to put. They don't know what should be the timeout and what should be the retry. So we're sort of doing it for them, and we're continuously dynamically updating these parameters so that they're going to be optimal. So that's just like a look in the future. Into the future. And okay, so this is what I wanted to say today. And just as a summary, I'm very excited about this project, and it really helps enterprises to deliver innovation, not just, but also with security and with control and with insight. Okay, thank you.
So I'm actually going to ask the first question.
Yeah.
In your vibrant community, I'm going to ask you to add F5 to that list.
Oh, yeah.
Because we have an F5 incubator called Aspen Mesh that are developing enterprise services on top of Istio. So that surprises a lot of people. They're probably like, why is that F5 guy emceeing that talk? We're actually part of that community as well, because we know there are many different platforms. There are still many different apps that are like legacy kind of architectures, but there's a lot of the new stuff as well. So we're kind of evolving with that, and we're really excited to be working with Istio and contributing back as well. We've got a team of people out in Colorado. So my one ask is that we get thrown up there as well.
Yeah,
And I very cheekily did that in front of an audience of witnesses.
But I will add F5.
So any questions from the audience for tomorrow? That means you did such a good job that there was nothing left to ask. That's the only thing that could mean, I think.
Here, there is a question over there.
Yes.
Yeah, Envoy 07. That's exactly what's going on with the mutual TLS authentication, which is given by Citadel, and that's one of the things that, we're giving you security out of the box. Yes, the CA, Central Authority Management, Okay, thank you.
Ying Seong, arquitecto jefe, plataforma en la nube, Huawei. A medida que la informática de vanguardia se vuelve más importante, muchas de las tecnologías descritas anteriormente, desde contenedores hasta microservicios, deberán evolucionar para adaptarse a los requisitos restringidos de esos entornos operativos. Seong acercó a los asistentes a través de las formas en que Kubernetes puede usarse en implementaciones informáticas de vanguardia.
So, good afternoon. Thanks for coming to my talk. So my name is Yin Xiong. I'm the chief architect of cloud platform at Huawei. So in this talk, I'm gonna talk about the project we're doing is called Edge Cloud, and share some experience we had with you about how to use the Kubernetes to manage the nodes on the edge, and how run the applications or containers or serverless functions on the edge platforms. So a little bit more about myself. So again, I'm a chief architect of a platform called PaaS, Pizza as a Services. So platform as a services is cloud native one that we have. So that's my main responsibility. Besides that, I also manage a lab here in Seattle for Huawei. It's called Cloud Lab. We do kind of interesting project in the lab, including the cloud networking and cloud storage, and some of the AI, of course. So we're also hiring. So if you know somebody that's looking for a job, hey, talk to me. We have some hiring there. So Huawei actually is a founding member of CNCF Foundation. So we are, I'm part of the kind of board members representing Huawei in the CNCF Foundation. So we're doing a lot of projects with CNCF, including Kubernetes. We contribute a lot in the Kubernetes. We're also doing some other projects. Actually, we're also doing Istio, try to work on the Istio side too. Before Huawei, I worked for Microsoft. This is Seattle. Everyone has worked for Microsoft at some point. Before that, I worked for AT&T. Anyway, so again, it's talking about the cloud, edge cloud. So what it is, edge cloud? And of course, pretty sure that you have your own definitions. So everyone has own definitions. For us, we define the edge cloud as those characteristics. One is the computing resource at the edge that managed by the cloud. So I say managed by cloud. If you have edge in the computer is not managed by cloud, we think that's not part of our scope for our project. So that's what we call edge cloud. And you could call edge computing, it's not managed by cloud. And so that we think that edge cloud is an extension of a central cloud. This morning in this on-stage interview talk with Mark from Microsoft, he's talking about the agent is the train, and that's where the it's extension of the cloud. So we think it's the same thing here. Also, the resource ownership in the servers on the edge could owned by cloud provider. Like the Huawei is actually we have own public cloud, or owned by customers. So that's a little bit different than the centralized cloud where the servers are owned by the cloud providers. Now, when they're owned by customer, and in order to actually make the edge cloud works, the customer has to authorize the cloud providers to manage the resources, which is the edge servers here on the edge. So that's kind of a little bit different than that. Also, app are scheduled deploy onto the edge from cloud. So that's not pre-installed app in the edge servers. That's not locally installed deploy. Is actually deployed from the cloud. So that's another kind of characteristic for the edge cloud perspective. That is the bi-directional communication between the edge and the cloud. You can look at the CDN is kind of one direction, right, from cloud to the edge. But then that's it. So in the edge cloud, in our scope, it has to be bi-directional communication between the edge. We have edge information about the applications, about the status of the nodes has to be sent back to the cloud, so cloud be able to manage that. So that's the edge cloud that we define, and this is the project we're doing. Now, why we're doing edge cloud? So I don't think I have to convince you why we're doing that. Microsoft just announced the IoT edge cloud platform, and again, this morning in the on-stage interview with Mark from the Microsoft, he's talking about the trends of edge, whether it's for data privacy, whether it's just huge data, or whether it's just the latency requirement for your applications or the network bandwidth you have that is not good enough to the cloud. And those are all the reasons they wanted the cloud. Now, for us, we'll have a couple of scenarios that we want to do edge cloud. One is the video surveillance scenarios we have. This one actually is very popular in China, where if you got a chance to went to some of the big cities in China, almost every traffic light there has videos. the surveillance to monitor the traffic, monitor whoever to violate the traffic. So there's a lot of resident communities in China that has the videos surveillance there in the gate or in the community door where monitor suspicious people is going to come back and through, and all the cars trap back and forth between the enter the community and out of the communities. And that's one of the scenarios we want to do. And in fact, with part of the project, we're doing a POC with some of the customers actually doing that, helping them doing that. Another one is industrial IoT scenarios, and I don't have to emphasize this. A lot of our customers, they are IoT scenarios. They want to run these applications on this very little, sensors, and we call edge to we can consider as edge too. All the sensors connect to a servers. The servers as running the edge applications. Huawei also has the smart home scenarios, which is what we actually manufacture another smart home watches, smart home appliances, and this is where they also want to run some applications or serverless functions inside of the home smart appliance. So these are scenarios we want to do edge cloud. Now some of the challenge we have here. First is, of course, it's the resource constraints. It's not in the centralized data center. So we've seen a range of computing node, the edge nodes from 64 megabytes memory to 250 megabytes computer servers that on the edge. So we need to manage this. So it's a range of resources, computer nodes. Well, even with a large, powerful servers on the edge, we have a customer tell us that they only assign a couple hundred of megabytes for us to deploy the platform there, because they want to need more power, more memory to run the application itself, especially for AI applications over there. So for us, that's the challenge is we have to make the platform really, really lightweight to run on those different type of the edge nodes that has different set of configurations in terms of resource perspective. The second challenge is network stability. As you say that the servers, the resources, the edge, on the edge where it's really, you can't assume that it's always connected. You will be offline sometimes, you're connected. So that actually poses our requirements to us. Basically say, whenever that you lost the network connection, the application running on the nodes has to be managed itself. That means has to manage itself. So we have to have the solutions to handle those scenarios, and that's one of the challenges I have. Especially, in fact, some of the edge customer we have, the customer actually own the edge servers, edge nodes, but this server is not in the public network, in the private network. So how do you manage that from the cloud when the servers on the network is not public? So that's another challenge we have. I have some solution there I can talk about later on this. It just that we have the scenario where the edge nodes is not accessible from cloud. And the other side of the challenge is the manage the multi-tenancy on the cloud, on the edge resource from the cloud. You think about the edge could have different. It's actually we have a services called edge cloud services. Actually manage the edge for different customers, which means different tenants, right? And then now you imagine could be a lot of the edge nodes, and each edge node has to be isolate each other, even go through the same channel in the or same services in the public cloud. So that's manage the multi-tenant edge. It's kind of a challenge for us. We have to make sure that if the customer try to deploy the applications on the edge where you deploy to the other customer edge, that will violate this multi-tenancy policy, right? We don't want to do that. You don't want this to happen. We also do have requirements that how to communicate edge to edge. So they'll have edge cloud, edge servers on the one side, another edge server on the other side. They want to communicate each other in case their connection is dropped or connection is lost from the cloud. So we do have those requirements there too. So that's kind of all the challenge we have for this project that we are doing, edge cloud. So the first thing we try the Kubernetes. Since we already, Huawei has our own public cloud services. We have container services based on Kubernetes. So the first thing we say, okay, let's try to using the Kubernetes to manage the nodes that are on the edge. right? And then actually the Kubernetes is not designed to manage nodes for the edge. So, but this is the first thing we try, and then we encounter a couple of problems. The first is what happens when the edge nodes the loss of network connection. That's obvious. And based on the design of Kubernetes, where if you lose the connection, you cannot update the node status to the cluster on the Kubernetes. Kubernetes saying that load is not there, will eject the node from the cloud, from the clusters. So then you cannot deploy applications there in the node. So those are the problems that they have when you actually using the Kubernetes to manage the nodes that are actually away from the data centers on the edge. They also have other problems too. And the applications running on a node normally will send a status, right, kind of heartbeat to the cloud on the cluster called Kubernetes masters. Now, once the connection is lost, what happened to this status? What will happen to the app? You know what? The Kubernetes, which is running on the edge, will actually shut down the applications. Because they don't know what they should do for the application or for their containers. So those are the problems we encountered when we first tried that. Second is a lot of applications running this platform on the edge, and they want to send the data to the cloud, to the cloud. No, we don't have a platform, or Kubernetes doesn't have this built-in mechanism in the platform to provide a channel for applications to send the data out to the cloud. They have to do it themselves. But if we run many applications there, and then every application has to do their own. So we would like to have the platform that actually provide the capability that the communication channels for the data itself. So for applications to send out, they put the data there, they automatically guarantee they manage, sync back to the cloud, or send to the cloud. There's no serverless functions at the edge support. That's, of course, is not part of Kubernetes. But we do have those requirements where we want to run the serverless functions push to the edge. The servers are running. Of course, when just push the metadata, the functional definitions into the edge. Now, when this function running is based on the events happen on the edge, not happen in the cloud. So we want that kind of capabilities in our platform. So I'm going to talk about later about this. This is kind of a challenge we have when we first try using Kubernetes manage the edge nodes away from the cloud. So based on those challenges, our current requirement, and we come up with this architectures that we have. And we still try to leverage as much as possible on the cloud side for using the Kubernetes itself. We're saying this very flexible architecture we can extend it for the cloud edge. So in that architecture, we first realized that we have to build a communication channels, the robust communication channels between the edge and the cloud, and that's fundamental. We want to make sure that communication channel is reliable and it's scalable on the cloud side. It's assumed that we're running many nodes, managing many edge nodes from the cloud. So that means that if the network connection is lost, this communication channel has to keep trying to establish the connections, and when it's connected to the cloud. So we have to make that. So first thing we build up is we call cloud hub or edge hub. One is on the cloud side, one is on the edge side. We can make sure this communication is always open. So for the data or for management plan or control plan, the information back and forth between the edge and the cloud. So I can talk about a little about that. The second kind of components we build for this architecture is edge controller, we call, which edge controller is actually using the Kubernetes controller plugin, building this edge controller. What the controller do is on behalf of edge nodes, to interact with Kubernetes cluster on the cloud. So it's not only kind of virtual nodes, you will say, the virtual edge nodes they have, but that controller is on behalf of edge nodes to manage the connections, manage the data, manage the command from the cloud, push functions to the edge. So we call edge controller. The second is, we mentioned that when the network is on the edge side, when the network is not connected or offline, And in order to do that, we have to build a metadata sink and into the from the cloud back to the edge, so that when the connection is gone, we still have a metadata which including the functional definition or the container images or the what we call application specification or application configuration. So we can the edge itself can manage themselves, can restart it, the functions or the containers on the edge. So that's why we have to build this edge metadata sink. The next component we have to build is we call Kuber Edge, which is the agent, which we call a agent on the edge, which is actually optimized Kubernetes. If you know the Kubernetes is a Kubernetes running on the nodes, so it's optimized the agents on the edge where actually manage the applications and the containers and the functions, serverless functions on the edge. And you basically watch, if you know the Kubernetes, you basically watch ECCD, which is have the application specifications there, and as a local store, and watch there, and then try to manage the applications. Start up the application, operate the application, or in this case, it's containers or the functions. You also listen to the events from the devices. If this is the edge, that when the events happen, it will trigger you will manage or stop some functions to process the events. So that's kind of what we call it, Kuber Edge is again optimized the Kubernetes to manage the life cycles on the edge. I can talk about a little more on this on the later slides. The last component we built for that whole architecture we have is the event hub. There's basically currently we support HTTP and MQTT, which basically that we have events for your device, from the devices that to the edge, like your temperature change, your whatever the device they connect to the edge, and they will send out the events. And that events will trigger the functions to run and to process the events in these functions locally on the edge. So that's the kind of high-level architecture we have. By no means this is kind of only or best architecture we have. We are working with some of the customer POC, doing POC to verify this architecture, especially from kind of edge perspective. So latest, the rest of slides, I'll just talk about a little bit more on those components we have. First, I mentioned there is a cloud hub and the edge hub, which is we built it as a custom protocol, network protocol over TCP/IP, that designed for edge communication and the edge and the cloud communication. And the key here is make it reliable, make it sure that it's fault tolerance. Because that when you lose a connection, this hub has to try to make a connection to the cloud and always make it the connections, try to make a connection to the cloud. Especially if the edge is in the private network, has and no access from the cloud. So this hub, basically on this side, in this case is the edge hub, have to make a connections to the cloud from the edge to the cloud, and keep the connections there. This is that's called long connections. So that when a message or command try to push it from cloud to the edge, it will leverage this connection. And this is sometimes called the multiplexing the channels, where you make a connection from the edge to the cloud and keep it connection, so that when the cloud side want to push some information or some command back to the edge, you can leverage the connections there. So that's kind of key part of this edge hub on the cloud hub. Again, it's a very reliable directional multiplex channel, and then again with scalability on the cloud side. We mentioned that this edge on this servers on the edge, it could belong to different tenants, and then we have to manage it, for security, for other reasons, and so that's really a multi-tenancy. Even for the connections, you have connections that come from different tenants. Edge server to the cloud, we have to make sure those connections are isolated each other so they don't impact each other. So that we have to build in that capability inside of this communication hub or channels. Today, in our kind of POC with customer, we do support HTTP with this communication between this cloud and the edge. We plan to support WebSocket and gRPC, of course, native TCP/IP. That's we're working on that. For security, each node right now is very basic. Basically, each edge node using certificate to authenticate itself to the cloud, so they can, when the edge register himself to the cloud, we will download this certificate in the edge and make sure that's valid edge nodes that we manage from the cloud. So that's edge cloud, and this edge controller I mentioned earlier, which is the components on the cloud side. Again, is manage the edge nodes, including the register the new edge nodes. That's basically work on behalf of the edge nodes that work together with Kubernetes master in this case. So, for example, that in the users can using the standard Kubernetes API to deploy their applications from the cloud, right, using the Kubernetes API. Then the edge controller will watch this change, watch this. Okay, this is a new application, a new pod, we call pod, right? Try to deploy, and then watch this and actually deploy to the edge nodes. And how to deploy? It will go through the cloud hub or the edge hub that we're talking about, and then push that specification into the nodes, and the node, the Kubernetes edge will take that and then store or start these containers on the edge. So that's how this whole process works. So the edge controller basically work on behalf of the edge nodes, and it could be work on behalf of one node or 100 nodes, and so it will be scalable to manage that many of nodes from Kubernetes perspective. At the same time, where the edge we call Kubernetes edge, which is running the agent running on the edge, you will actually do the heartbeat of the node itself. So the node status and the application status, which is container or pod status, will keep in sync back to the Kubernetes and the cloud, and that will edge controller also watch that too. Edge controller also watch any status change about the nodes, the edge nodes, and the applications running on the nodes, and sync that into the Kubernetes masters too. Yeah, so the weather keep it sync. And so from outside perspective, it's standard Kubernetes API. Customer just deploy the application, but underneath it, go through this cloud hub or the edge hub and deploy the functions, manage the functions, or the containers on the edge nodes. So that's the whole idea, in fact. Metadata sync, and this is a kind of very important components we have in our architecture. It basically is designed for where the edge node is offline. And we want to make sure the applications running on the container running on the edge is still running. And if they crash, we still have ways to start up. And then if the node is actually disconnect from the cloud where the cloud sync, the node doesn't exist, but we don't want to then shut down the applications on the edge. So we have to sync the metadata there from the cloud to the edge. This we actually have using a trimmed down version of etcd. If you know the Kubernetes, the etcd is behind the store of the API server and the Kubernetes API server, and we kind of the etcd has kind of 3 layers itself, and one is the multi-version, the continuous control layer, which is like a store. We keep it that, and then we remove the gRPC, which is interface. We remove the wrapped consistency, and which that piece. So we have a kind of mini version of etcd that has watch capabilities. We actually install that into the edge. Now the reason we're doing that is we have some edge, just like a Raspberry Pi, very small memory, so that we can run it on there. In fact, I think we're already running on we try one of the POC, we try a demo. We actually just hosting the architecture on the edge. We actually run a Raspberry Pi. A Raspberry Pi is 128 meg memories of the devices running there. And the etcd minimum is just occupy less than 1 megabyte memory is there. So that's the reason we're doing this trimmed down version of etcd. But it works actually pretty well on the edge side, where we have a Cooper edge which constantly watch this. So we don't change the behavior of the CuberNet, which is we optimized for the Cooper edge. So at the same time, I think I saw say that again, the edge, the application, which is a part in this case, the spec change, including the new deployment, or the remove existing app. If the customer say I want to delete the app from running on this edge, they can call the API in the cloud, which is sync their actual specific metadata into the edge, and then Cooper edge will find out it, and they will delete or remove or shut down those applications or containers on the edge. So that's how the process works. That's one direction from cloud to edge. Now, from edge to cloud, you leverage the same channel, communication channel there. The Cooper edge has the same heartbeat capability like CuberNet, where heartbeat, the node heartbeat information and the CuberNet, the application status back to the cloud. So the Kubernetes master will have this have the information of there. The good for that is the customer, from customer perspective, I looking from a cloud side, I can see all these edge servers running there. I can see all the applications running on which application running on the which edge nodes. So I can manage and see, review from the cloud side. That's why we have to sync the data there from node to the cloud. Cooper Edge, I mentioned a little bit that is kind of manage the runtime environment for the edge nodes and manage the application lifecycle. Start it, stop it, and upgrade it or restart it based on the events. So that's the Cooper Edge. Again, it's an optimized version of CuberNet and manage the lifecycle for containers or functions. And they can work offline when the network connection is lost. I mentioned that also. And it also responds to the edge. There's something we added to it is for the serverless functions. The event happened on the edge. And the event happened on the edge through the event channel where Cooper Edge responds to the edge events and start corresponding functions on the edge or containers on the edge. So we have, during the event registration on the edge, we have to keep a mapping between the events and the functions or containers. So that metadata also is created in the cloud, but again, sync back to the nodes. Now the nodes, of course, in the cloud, you manage a lot of nodes, hundreds or thousands of nodes. They are from different customers. Not all the nodes that actually sync data, only sync the data that relate to the nodes, is sync it back to the nodes, not other stuff. So I think that's it. That's probably what I have for this, for my presentations. Okay. Any question? Yeah. So in fact, that's a good question. We are in the process to try to open source Cooper Edge in the and a communicating channel too. So we're not there yet, but we are trying to open source that. This is SainSafe. We'll plan to that. We have not talked to the SainSafe yet. Yeah, but that's the plan. Well, function runtime, we have a couple of function runtime ourselves. We build in, well, first of all, function, we also package as a container, so that's the same. And then, but we have a runtime for when the container start up. We have passive runtime we build ourselves, and the Java Go runtime there. So the runtime is already there. When the first node register with cloud, we download the runtime into the nodes. That could be something else. Right now, we build our own for the serverless functions there. The one piece I did not mention there is if the edge is very small, I mean very lightweight, like 128 meg memories, we have a lightweight containers that run in these functions, all the applications. And that container actually conform to standards of OCI but it's not standard Docker, because in that scenario, standard Docker is still too large. The Docker runtime, if you're running Docker runtime, it's all 100, you're already 100 or maybe 200 megabytes already. Normally it's 100 megabytes already. So that's too big, in fact, and that in that scenarios. So we do have a live version of containers we're working on for those scenarios. Yeah. Most of the services in the preview stage in our public cloud. If you actually go to Huawei public cloud, which is huaweicloud.com, we have a service called, I remember it's called Edge Cloud. I think it's called Edge Cloud Services. And then you can register nodes, start to play around with it. In fact, yeah. Around there. How to load balance the nodes, the edge nodes? That's a very good question. We do have, one of the architecture we have, I did not show there, is the Kubernetes master in the cloud. We could run many instances of that. And then when a node registers to the cloud, we have a component that we call placement, which actually decide which clusters you will register with, so that each node only belongs to one cluster. And of course, we can run many clusters in the cloud. And that's where we manage the load balance, the edge node.
Is now turned on. Now, once again, any other questions? That is all. I believe that concludes our
Thank you.
DevOps and containers track for the day. Thank you for coming along. Hope you've enjoyed our speakers.
Conclusión. Magníficos aportes de expertos de primer nivel para conocer de primera mano cuál es el presente y futuro del desarrollo de software. Danos tu opinión en los comentarios. Contacta